Hi everyone, welcome to our demo. Gradients in deep learning are often too big to handle efficiently. In this video we introduce MetaStore, which makes gradient analysis practical and efficient. We'll walk through a real-world mislabel detection task to show how it optimizes gradient storage and computation. We start with uploading a noisy training dataset. This can be done easily by dragging and dropping files or simply clicking a button. MetaStore supports multiple data formats, including images and text. In our demonstration, we're using the CFAR10 image dataset, saved in multiple pickle files. We can simply upload the entire training dataset folder. As the upload starts, user will see a progress bar, and a preview of some uploaded samples will pop up automatically. The rest are neatly hidden under the More Files area to keep things organized. Users can click on any image to zoom in and inspect details. For example, here we can see a close-up of a bird image used as a training sample. Next, in the Model Upload section, users provide their pre-trained model, both the architecture file and the corresponding weight file. After clicking the Upload Model button, MetaStore analyzes the model and displays its structure in a clean, tabular format. This includes the name of each layer, the output shape, and the number of parameters. If needed, users can also download the full model summary by clicking the Download button. After that, users can choose the specific layer they want to analyze using a drop-down menu. In our demo, we select the final convolutional layer of the VGG16 model. Once the layer is selected, clicking the Model Replay button triggers the system to replay the model using the uploaded training data and compute gradients for the selected layer. Instead of storing the full gradients, which can be extremely large, MetaStore uses an innovative compressed format, prefix and suffix gradient pairs, to significantly reduce storage and computation cost. As we can see, on the right side, users can see this performance gain visualized clearly. The bar chart on the left shows storage differences. Storing full gradients would take up 94,371 megabytes, whereas MetaStore's optimized format uses only 163 megabytes. The pie chart compares query time, highlighting how our decompression-free gradient analysis far outperforms traditional approaches. Users can hover over any visual element to view more details through interactive tooltips. Finally, the resulting compressed gradient data can be downloaded as a .npz file by clicking the Download Results button. MetaStore currently supports 3 popular data tasks designed to help users explore a wide range of gradient-related problems. Let's begin by clicking the Let's Analyze button, which brings up the task selection dialog. Each task is centered around data and comes with a brief description to help users understand its purpose. In this demo, we'll focus on mislabel detection. After selecting this option, the interface automatically navigates to the Data Task Analysis page, which is divided into 2 main sections. Just like before, uploading the data is simple. Users can drag and drop or click to upload a clean validation dataset. Different from the previous previews, each validation image is now displayed with its label overlaid for easy reference. For instance, here we can see that image number 2 is a cute puppy. Users can use the toolbar below to zoom in, rotate, or adjust the image view. Once the upload is complete, we scroll down and click the Analyze button. MetaStore will now compute the inner product between the gradients of the validation samples and those of the training samples to detect mislabeled entries. After a short wait, the analysis results are displayed across the right-hand sections of the interface. It will mainly consist of 2 parts. One is the analysis results and the other is a preview of the mislabeled samples in training dataset. As shown below, a bar chart illustrates the distribution of training and validation data, and a donut chart visualizes the proportion of detected mislabeled samples. Below that, MetaStore lists the downloadable outputs, including both the validation gradients and a cleaned version of the training set. These files are packaged in standard formats like .npz and .zip for convenient offline use. On the far right, there is a visual preview of training samples that are most likely mislabeled. Each image is shown with its predicted label underneath. For example, image number 0 is a yellow cat that was incorrectly labeled as a bird. Mislabeled samples are also available for one-click download. If users want to explore other tasks, they can simply click the Let's Analyze button again in the middle of the page to return to the Data Task Selection dialog. Importantly, switching tasks does not require re-uploading the model or training data, allowing users to perform in-depth analysis across multiple tasks. And if at any point users want to update the configuration, they can just click the MetaStore logo in the top left corner to return to the Start page and begin a new session. This video demonstrates how MetaStore enables efficient analysis of large gradient metadata, making previously infeasible tasks practical.